Okay, so let's look at this problem. I'm not sure where you're saying you don't understand where they're getting the second equation, so I'm just going to do the problem from the beginning. So I'm going to write down here, and then I'll slide it up so we can see a little bit more of the screen. But the easiest way to set up these problems is to create a table. So, and you're going to have, this is kind of like a solution problem or combination problem. You're going to have a mixture of two different things. And so a dairy farmer wants to mix a 75% protein supplement. So we're going to label that 75% protein supplement and a 50% protein supplement. And you're going to combine those two things together to make a ration of 1,400 pounds of a high-grade 70% protein. Oh, that doesn't look. Okay, so we've labeled our variables. And then we come back here and we look at the problem. And it talks about 75%, a 50%. We got 1,400 pounds. So we've got some percentages, we've got pounds. So we are going to need an amount in pounds. That's going to be one of our columns. And then another column is going to be the concentration. And then the final column is going to be basically the amount of, oops, I must have gotten into some other thing. Here we go. Amount, nope. Of protein. Okay, so if we go back to the problem, we don't know how much of the 75% protein supplement we have, so we're going to call that one X. We do not know how much of the 50% protein ration we have, so we're going to call that one Y. We do know that we have 1,400 pounds of the 70% ration. So the concentration is just your percentage as a decimal. So this one is 0.75. This one is 0.50. This one is 0.70. And then to get the amount of protein, you're going to multiply the amount of pounds you have times the concentration. So it's going to be column 1 times column 2 is equal to column 3. So 0.75x, 0.50y, and this one is 0.70 times 1,400. Okay, I'm going to slide this up now. Okay, so we have two equations, two unknowns. That's what we need anyway. When we have two unknowns, we need two equations. So here we can get our amount in pounds because we know that we have X pounds of one, Y pounds of another, and that equals 1,400. So that's one of our equations. X plus Y is equal to 1,400. And then over here, we can figure the same way. The amount of protein that we have in the 75% solution plus the amount of protein that we have in the 15% ration is going to be equal to the amount of protein we have in the combined piece here. So Now we're going up and down like we did over here. And this is our second set of equations. So our second equation is going to be 0.75x plus 0.50y equals 0.70 times 1400. Okay. Gotta get a calculator going here. Okay, so now I'm going to, I've saved that whiteboard. I'm going to get us a new new whiteboard here real quick. Okay, so let's go ahead and solve that system that we just had up there. So x plus y was equal to 1400. And then we had 0.75x plus 0.50y equal 0.70 times 1400. Okay, so the first equation represents total pounds. And the second equation represents how much protein out of all those pounds was in this mixture. So just thinking about it, I mean, we have a 75% mixture, a 50% mixture, and we're trying to get a 70% mixture. So if you think about it, which of these concentrations do you think we're going to have more of? Probably the bigger one, right? So we just have to reduce it just a little bit right here with, oh gosh, I wrote on there. You just have to reduce it a little bit with the 50% protein concentration. All right, so now you can choose to solve this system of equations however you would like to. It doesn't really matter. So I am probably going to just use elimination because that's what I like to do. So I am going to multiply this top equation, the entire thing, times negative 0.75 because I want to get rid of that variable. So now my new equation down here, I'm going to write it underneath. Negative 0.75x minus 0.75y equals negative 0.75 times 1400. Okay, so now if we do the math, not necessarily too much math to do over here on the left, but we do have to do some multiplication over here on the right. So with elimination, remember, you're eliminating some of your variables. So the 0.75x and the negative 0.75x are going to add to 0. 0.5y minus 0.75y is negative 0.25y. And then 0.7 times 1400 is 980. And then 0.75 times 1400 is negative 1050. So when you take 980 and subtract 1050, we end up with negative 70. And then when we divide that by negative 0.25, y ends up being 280. So let's slide this down again for a second and see. I'm trying to figure out, you didn't actually get that answer, did you? I'm assuming that the answer you have on your paper that you sent to me, 700 and 700, is what you have, and you didn't submit your answer yet. So, because 700 and 700 is not the correct answer. So I was looking back. So if y is 280, then to figure out what x is, we can just plug that y in right here, back up here. And so x is going to be 1400 minus 280. Which is 1,120. So you have 280 pounds of the 50%, and you have 1,120 pounds of the 75%. And remember, when I started working through this problem, we talked about the fact that since you had a very high concentration in your mixture, you're going to have more of the higher concentration protein than you would the smaller concentration protein. So that sort of works out here. You can see that we do have more of one than we do the other. Okay.